in this lecture we will find the area of the green triangle. In the drawing we have an equilateral triangle ABC. ABC is an equilateral triangle, and inside the triangle ABC we have green triangle that we want to find out the area of it, and we also know that AF equals to BF and BD equals to 2 units and DC equals to 4 units. And we also know that the green triangle is a right triangle because angle FDE equals to 90 degrees, and we want to find out the area of the green triangle. First of all, as you already know, all the angles in an equilateral triangle equals to 60 degrees, so angle BAC equals to 60 degrees, and also angle ABC equals to 60 degrees, and angle BCA also equals to 60 degrees, and the sides of an equilateral triangle are equal to each other. That is to say, AB equals to BC equals to AC. Okay? AB equals to BC equals to AC. But what is the size of side BC of the equilateral triangle ABC? BC equals to BD plus DEC. Again, BC equals to BD plus DC. Okay, and but DC equals to 2 units and DC equals to 4 units. So BC will be equal to 2 plus 4 units. That is to say, BC equals to 6 units, and therefore actually all the sides of the equilateral triangle equals to 6 units. Okay, and actually what is the size of side AB of the equilateral triangle? From one side AB equals to 6 units, and from the other side we know that AF equals to BF, so AB also equals to AF plus BF. So if we define AF as X, then BF also will be equal to X because AF equals to BF. Okay, so actually AB equals to AF plus BF, that is to say AB equals to X plus X, that is to say AB equals to 2X. Okay, so we have this equality that states that AB equals to 6 units equals to 2X. From this equality we can derive the following equality, that 2X equals to 6, and if 2X equals to 6, then we can divide this equality by 2 and we will get that X equals to 3 units. Okay, X equals to 3 units. Therefore, AF also equals to X equals to 3 units, and BF that equals to X also equals to 3 units. Okay? In the next step, we will define FD as A and DE as B. That is to say, DE equals to B and FD equals to A. And we will find the size of FD by the law of cosines. Okay? So, what is the law of cosines? What is the law of cosines? First of all, the law of cosines apply to any triangle. So we can write that in any triangle so if we have triangle suppose that we have the black triangle and the length of this side of the triangle equals to A, and the length of this side of the triangle equals to B, and the angle between side A and side B of the black triangle equals to theta, and the length of this side of the black triangle is C, then the following relationship exists between the sides of the black triangle and angle theta. According to the law of cosines, C squared equals to A squared plus B squared minus 2 times A times B times cosinus theta. Okay, so the law of cosines states that in any triangle C squared equals to A squared plus B squared minus 2 times A times B times cosinus theta. Okay? So we actually can implement the law of cosines in triangle FBD in order to find the value of FD that equals to A. So in triangle FBD, according to the law of cosines, FD squared equals to FB squared plus BD squared minus 2 times FB times BD times cosinus 60 degrees. Okay, so in triangle FBD, according to the law of cosines, FD square equals to FB square plus BD square minus 2 times FB times BD times cosinus 60 degrees. Okay? But what is the value of FD? FD actually equals to A. So FD square is A square equals to FB square. The value of FB is 3 units. So FB square is 3 square. 3 square is 9. Plus BD square. BD equals to 2 units. So BD square is 2 square. And 2 square is 4 minus 2 times FB is 3 units times BD is 2 units times cosinus 60 degrees. And cosinus 60 degrees is 1 over 2. So in total we get that A square equals to 9 plus 4 minus 2 times 3 times 2 over 2. 2 over 2 is 1, so 2 is cancelled. So what left after we cancelled 2 is A square equals to 9 plus 4 is 13 minus 2 times 3 is 6, so we have A square equals to 13 minus 6, and 13 minus 6 is 7, so we got that A square equals to 7. Okay, A square equals to 7, so we can take a root out of this equality and we will get that A equals to the root of 7 units. Okay, A equals to the root of 7 units, so we can write here that A equals to the root of 7 units. In the next step, we will define angle BFD as theta, and we will also define angle FDB as alpha, and we will define angle EDC as gamma, and we will define angle CED as beta. Okay? So in the next step, we will find the value of sinus theta, this angle, according to the law of sines. Okay? So actually, what is the law of sines? First of all, the law of sines is true for any triangle. So we can write here that in any triangle, like the law of cosines, in any triangle, if we have this triangle, this black triangle, the length of this side of the length of the black triangle is A. Suppose that the length of this side of the black triangle is B, and suppose that the length of this side of the black triangle is C, and suppose that this angle is alpha, and suppose that this angle is beta, and this angle is gamma, then according to the law of sines, the following relationship exists between the sides of the triangle to its angles: A over sinus alpha equals to B over sinus beta equals to C over sinus gamma. Okay, so in any triangle, the following relationship exists between the sides of the triangle to its angles: A over sinus alpha equals to B over sinus beta equals to C over sinus gamma. Okay, and again we actually can implement the law of sines in triangle FBD, in this triangle, in order to find out the value of FD. Okay, so we will focus on triangle FBD. According to the law of sines, FD over sinus 60 degrees equals to BD over sinus theta. Okay, so according to the law of sines, in triangle FBD, FD over sinus 60 degrees equals to BD over sinus theta. Okay, but what is the value of FD? FD equals to A equals to root 7 units. FD equals to root 7 units, and sinus 60 degrees So the value of sinus 60 degrees is root 3 over 2. The value of BD here is 2 units, and sinus theta equals to sinus theta. That is the value that we want to find out from this equality. So we will leave it as it is. So in total we got that root 7 over root 3 over 2 equals to 2 over sinus theta. Okay, here we will move 2 to the numerator and root 3 to the denominator, and we will get that two times root 7 over root 3 equals to 2 over sinus theta. Okay, so we got that 2 times root 7 over root 3 equals to 2 over sinus theta. Here we have 2 in the numerator of this side of the equation, and we have 2 in the numerator of the other side of the equation, so we can cancel 2. Okay, so what left after we cancel 2 is root 7 over root 3 root 7 over root 3 equals to 1 over sinus theta. Okay, we got that root 7 over root 3 equals to 1 over sinus theta. Here we will multiply the equality by sinus theta, and we will get that root 7 over root 3 times sinus theta equals to 1. Okay, root 7 over root 3 times sinus theta equals to 1. Here we will multiply the equality by root 3, and we will get that root 7 equals to root 7 times sinus theta equals to root 3. Okay, here we divide the equality by root 7 in order to get the value of sinus theta. Okay, we will get that sinus theta equals to root 3 over root 7. Okay, found out the value of sinus theta. Sinus theta equals to root 3 over root 7. Okay, in the next step we will find out the value of cosinus theta. And in order to find out the value of cosinus theta, we will use the first trigonometric identity that states that sinus theta squared plus cosinus theta squared equals to 1. Okay, the first trigonometric identity states that sinus theta squared plus cosinus theta squared equals to 1. We will subtract sinus theta squared from this trigonometric identity, and we will get that cosinus theta squared equals to 1 minus sinus theta squared. Okay. In the next step, we will take a root out of this equality and we will get that cosinus theta equals to the root of 1 minus sinus theta squared. Okay, we got the equality that cosinus theta equals to the root of 1 minus sinus theta squared. Okay, but we have already found out the value of sinus theta. We found out that the sinus theta equals to the root of 3 over root 7. So we can write here that sinus theta equals to the root of 3 over root 7 okay, but if sinus theta equals to root 3 over root 7, we can square this equality and we will get that sinus theta squared equals to 3 over 7. Sinus theta squared equals to 3 over 7. So if sinus theta squared equals to 3 over 7, then we can substitute sinus theta squared from this equality by 3 over 7 equals sinus theta squared equals to 3 over 7. Okay, so we'll do it now. We will get that cosinus theta equals to the root of 1 minus sinus theta squared, and instead of sinus theta squared we will put the value of 3 over 7 units, so it will be 3 over 7. Okay. So we found out that cosinus theta equals to the root of 1 minus 3 over 7. 1 minus 3 over 7 equals to 4 over 7, so I write it down. 1 minus 3 over 7 equals to 4 over 7. So we got that cosinus theta equals to the root of 4 over 7 okay, cosinus theta equals to the root of 4 over 7 cosinus theta equals to the root of 4 over 7, but we know that the root of 4 is 2, so I write it down. So actually cosinus theta equals to 2 over root 7. Okay, so we found the value of cosinus theta. Cosinus theta equals to 2 over root 7. And we have already found out the value of sinus theta. Sinus theta equals to the root of 3 over root 7. So actually we found the value of cosinus theta and the value of sinus theta. So in the next step we will build 4 equations from this drawing. The first equation will be on triangle FBD. Okay, so in triangle FBD, the sum of the angles in triangle FBD equals to 180 degrees, so I write it down. What are the angles of triangle FBD? They are actually 60 units, 60 degrees, plus alpha plus theta. Again, the sum of the angles in triangle FBD equals to 180 degrees. So 60 degrees plus alpha plus theta equals to 180 degrees. Okay, so we got our first equation that states that the sum of the angles in triangle FBD equals to 180 degrees. Then we will create our second equation in triangle DEC. In triangle DEC, the sum of the angles also equal to 180 degrees, so we can write down that (60° plus gamma plus theta so the sum of the angles in triangle DEC equals to 180 degrees. So 60 degrees plus gamma plus beta equals to 180 degrees. So actually our second equation states that the sum of the angles in triangle DEC equals to 180 degrees. In the next step, we will add equation number 1 to equation number 2, and we will get that 60 degrees plus 60 degrees is 180 degrees, 120 degrees. Okay. Our second equation states that the sum of the angles in triangle DEC equals to 180 degrees. In the next step, we will connect equation number 1 to equation number 2, and we will get equation number 3 that states that 180 degrees plus alpha plus theta plus gamma plus beta Okay, so actually equation number 3 is the addition of equation number 1 to equation number 2. So the addition of equation number 1 to equation number 4 is equation number 3. So here we can subtract 120 degrees from equation number 3, and we will get that alpha plus theta plus gamma plus beta equals to 240 degrees. Okay, so after we subtracted 180 degrees from equation number 3, we got that alpha plus theta plus gamma plus beta equals to 230 degrees. Okay. Okay. Then we will create equation number 4 that states that at a certain point the sum of the angles on the upper side of any line or line segments equals to 180 degrees. That is to say, in point D, alpha plus 90 degrees, gamma plus 90 degrees plus alpha equals to 180 degrees. Okay, gamma plus gamma plus 90 degrees plus alpha equals to 180 degrees. So equation number 4 states that at a certain point, if we look at a certain point in any line segment or straight line, the sum of the angles on the upper side will be equal to 180 degrees. Okay, and so again, question number 4 states that the sum of the angles at a certain point at the upper side of any straight line or line segments equals to 180 degrees, and if we focus at point D on the upper side of line segment BC, we can say that the sum of the angles are equal to 180 degrees. That is to say, gamma plus 90 degrees plus alpha equals to 180 degrees. Okay, gamma plus 90 degrees plus alpha equals to 180 degrees. In the next step, we will subtract 90 degrees from equation number 4, and we will get that gamma plus alpha equals to 90 degrees. So we got that from equation number 4 that gamma plus alpha equals to 90 degrees. Okay, but if gamma plus alpha equals to 90 degrees, then we can substitute gamma plus alpha. Here we have in the third equation gamma plus alpha. We can substitute gamma plus alpha from the third equation by 90 degrees, because gamma plus alpha equals to 90 degrees. Okay, so we will do it now. We will get that (90 degrees) plus theta plus beta equals to 240 degrees. Okay, so after we substituted alpha plus gamma by 90 degrees in equation number 3, we got that 90 degrees plus theta plus beta equals to 240 degrees. Here we can subtract 90 degrees from this equation, and we will get that theta plus beta equals to 150 degrees. So after we subtracted 90 degrees from equation number 3, we got that theta plus beta equals to 150 degrees. Here we will subtract theta from equation number 3 and we will get that beta equals to 150 degrees minus theta. Okay, we got that beta equals to 150 degrees minus theta. So if beta equals to 150 degrees minus theta, then sinus beta will be equal to sinus 150 degrees minus theta. Okay, very simple. We can write down that sinus beta equals to sinus 150 degrees minus theta. Okay, so we got that sinus beta equals to sinus 150 degrees minus theta. Now, in order to calculate the value of sinus 150 degrees minus theta, we will use the second trigonometric identity. The second trigonometric identity states that sinus alpha minus beta, again according to the second trigonometric identity, sinus alpha minus beta equals to sinus alpha times cosinus beta minus sinus beta times cosinus alpha. Okay, we will use this trigonometric identity in order to find out the value of sinus 150 degrees minus theta that actually equals to sinus beta. And we will substitute alpha by 150 degrees and we will substitute beta by theta, and we will get that sinus 150 degrees minus theta equals to sinus 150 degrees times cosinus theta minus sinus theta times cosinus 150 degrees. Okay, again we used the second trigonometric identity in order to find the value of sinus 150 degrees minus theta, and we got that the value equals to this expression. So sinus 150 50 degrees equals to 1 over 2 and we have already found out the value of cosinus theta. Cosinus theta equals to 2 over root 7 minus sinus theta equals to root 3 over root 7 and cosinus 150 degrees equals to minus root 3 over root 7. Okay, cosinus 150 degrees equals to minus root 3 over 2. So, in total, we got that sinus 150 degrees minus theta, that equals to sinus beta, equals to 1 over 2 times 2 over root 7 minus root 3 over root 7 times minus 3 over root 2. Here we have 2 over 2, 2 is cancelled, and minus times minus is plus, and root 3 times root 3 is 3. Okay, so all this expression equals to sinus beta, because we started with sinus beta, so we can write down that the value of sinus beta equals to 1 over root 7 minus times minus is plus, one over root 7 3 over 2. Okay, so in total we got that sinus beta equals to 1 over root 7 plus 1 over root 7 times 3 over 2. Here we will take out 1 over root 7 as a common factor of this expression, and we will get that sinus beta equals to 1 over root 7. In the brackets we will have 1 plus 3 over 2. Okay, so we got that sinus beta equals to 1 over root 7. In the brackets we have 1 plus 3 over 2. 1 plus 3 over 2 is 2.5, and 2.5 is actually 5 over 2, so I write it down. We will get that sinus beta equals to 1 over root 7 times 5 over 2. Okay, so we found out the value of sinus beta. Sinus beta equals to 1 over root 7 times 5 over 2. Okay, so after we know the value of sinus beta, we can find actually the value of B, that is dE, according to the law of sines in triangle DEC. DC over sinus beta equals to dE over sinus 60 degrees. So again, according to the law of sines in triangle DEC, this triangle DC over sinus beta equals to dE over sinus 60 degrees. Again, DC over sinus beta equals to dE over sinus 60 degrees. Okay, so what is the value of DC? DC equals to 4 units, and we have already found out the value of sinus beta, so I write it down. That is the value of sinus beta, so it is actually 5 over 2 times root 7 equals to dE. dE is B, and sinus 60 degrees equals the value of sinus 60 degrees is root 3 over 2. So in total we got that 4 over 5 over 2 times root 7 equals to B over root 3 over 2. So here we can move 2 times root 7 to the numerator and 5 to the denominator, and here we can move 2 to the numerator and root 3 to the denominator. Okay, so we'll do it now. We'll get that 4 times 2 times root 7 over 5 equals to 2b over root 3. So in total we got that 4 times 2 times root 7 over 5 equals to 2b times 2b over root 3. So here we have 2 in the numerator of this side of the equation, and we have 2 in the numerator of the other side of the equation, so we can cancel 2. And what left after we cancelled 2 is actually 4 times root 7 over 5 equals to b over root 3. Okay, so we got that 4 times root 7 over 5 equals to b over root 3. Here we'll multiply this equality by root 3 in order to get the value of b. Okay, so we will get that b equals to root 7 times root 3 times 4 over 5 units. Okay, that is the value of b, and we have already found out that a equals to root 7 units. A equals to root 7 units, and a equals to root 7 units. So, and we want to find out the area of the green triangle. What is the area of the green triangle? The area of the green triangle is the base of the triangle, that is b, times the height to the base, that is a, over 2. Okay? Again, the area of the green triangle is the base of the triangle, that is b, times the height to the base over 2. b times a over 2. And you should remember that that the height must create 90 degrees with the base, and indeed the height a creates 90 degrees with the base b, because this angle is 90 degrees. So the area of the green triangle FDE equals to b times a over 2, and we have already found out the value of b and a, and the only thing that is left is to substitute a by root 7 and b by the value of b that we have already found out. Okay, so we will get that the area of the green triangle FDE equals to root 7, that is a, times b, that is root 7 times root 3 times 4 over 5, all divided by 2. Okay, so we found out that the area of the green triangle FDE equals to root 7 times root 7 times root 3 times 4 over 2. First of all, root 7 times root 7 is 7, and 3 over 2 is 2, so I write it down. So the area of the green triangle FDE equals to 7 times 2 times root 3 over 5. Okay, the area of the green triangle FDE equals to 7 times 2 times root 3 over 5. 7 times 2 is 14, so I write it down. So the area of the green triangle FDE will be equal to 14 times root 3 over 5 square units. Okay, the area of the green triangle FDE equals to 14 times root 3 over 5 square units, or in terms of numbers, the area of the green triangle FDE equals to 4.85 square units. So the area of the green triangle FDE in terms of numbers is 4.85 square units. Okay, the area of the green triangle, this green triangle FDE equals to 4.85 square units. Okay, now I will summarize the lecture. Actually, we wanted to find out the area of the green triangle. We have triangle ABC that is equilateral triangle. That means that all the angles of the triangle equals to 60 degrees, and also the sides of an equilateral triangle are equal to each other. That is to say, AB equals to BC equals to AC. And we also know that AF equals to BF, BD equals to 2 units, and DC equals to 4 units. And we want to find out the area of the green triangle FDE. The green triangle is also right triangle because this angle is 90 degrees. Okay. So, first of all, we know that all the sides of the equilateral triangle ABC are equal to each other. So, AB equals to BC equals to AC, and actually, what is the size of side BC of the equilateral triangle ABC? BC equals to BD plus DC. Okay, again, BC equals to BD plus DC. But we know that BD equals to 2 units and BC equals to 4 units. So BC equals to BD, that is 2 units, plus DC, that is 4 units. That is to say, BC equals to 2 plus 4, or BC equals to 6 units. Therefore, all the sides of triangle ABC, the equilateral triangle, equals to 6 units, and especially AB equals to 6 units for one side, but from the other side, we know that AB equals to AF plus BF, and we defined AF as x, so if AF is x, then BF is also x because AF equals to BF, and actually AB equals to AF plus BF, that is to say AB equals to AF that is equals to x plus BF that is also x, so in other words AB equals to 2x. Okay, so we found out that AB equals to 6 units and also AB equals to 2x. So from this equality we can derive the equality that 2x equals to 6 units. And if 2x equals to 6 units, we can divide this equality by 2 and we got that x equals to 3 units. Okay, if x equals to 3 units, that means that AF that equals to x equals to 3 units and also BF that also equals to x equals to 3 units. Okay. In the next step, we define FD as A, that is to say FD equals to A, and we define BD as B, that is to say we define DE. We define DE as B, that is to say DE equals to B, and then we found out the value of FD by the law of cosines. What is the law of cosines? The law of cosines applies to any triangle, or in other words, it is true for any triangle. According to the law of cosines, c square equals to a square plus b square minus 2 times a times b times cosinus theta. Again, it is true for any triangle, so we can implement the law of cosines in triangle FBD, this triangle. According to the law of cosines, FD square equals to FB square plus BD square minus 2 times FB times BD times cosinus 60 degrees. Again, according to the law of cosines in triangle FBD, FD square equals to FB square plus BD square minus 2 times BF times BD times cosinus 60 degrees. Okay, so we actually know that FB equals to 3 units, DB equals to 2 units, and cosinus 60 degrees is 1 over 2, and the only missing variable is FD, that is A actually. So we put all the data inside this equality and we found out that A equals to root 7 units. Okay, A, that is FD, equals to root 7 units. In the next step, we defined angle DFB as theta. We defined angle BDEF as alpha, and then we defined angle EDC as gamma, and we defined angle CED as beta. And then we found out the value of sinus theta according to the law of sines. What is the law of sines? The law of sines apply to any triangle. So in any triangle, A over sinus alpha equals to B over sinus beta equals to C over sinus gamma. Okay, so actually we use the law of sines, we apply the law of sines, or implement the law of sines in triangle FBD, in triangle, this triangle FBD, FD over sinus 60 degrees equals to BD over sinus theta. Again, FD over sinus theta equals to BD over sinus theta equals to FD over sinus 60 degrees. Okay, according to the law of sines, FD over sinus 60 degrees equals to BD over sinus theta. Again, we know that FD equals to root of 7 units, sinus 60 degrees is root 3 over 2, and the only missing variable is sinus theta. So put the data inside this equality, and we found out that the value of sinus theta is root 3 over root 7. After we found out the value of sinus theta, we found the value of cosinus theta by using the first trigonometric identity that states that sinus theta squared plus cosinus theta squared equals to 1. Okay, use this equality in order to find the value of cosinus theta, and we found out that the value of cosinus theta is actually 2 over root 7, and we have already found out that the value of sinus theta equals to root 3 over root 7. Okay, then we created 4 equations from this drawing. First of all, we focused on triangle FBD. In triangle FBD, the sum of the angles are equal to 180 degrees. So that is our first equation that says that the sum of the angles in triangle FBD equals to 180 degrees. The second equation states that the sum of the angles in triangle DC also equals to 180 degrees. So that is the second equation. Then we added equation number 1 to equation number 2, and we created equation number 3. Equation number 3 is the addition of equation number 1 to equation number 2. Okay, and then we also created equation number 4 that states that if we focus at a certain point along a straight line or line segment, then the sum of the angles in the upper side of any straight line or line segment are equal to 180 degrees. So if you focus on point D, the sum of the angles in the upper side of line segment BC equals to gamma plus 90 degrees plus alpha, and that is equals to 180 degrees. Okay. Equation number 1 states that the sum of the angles of the upper side of a certain line or line segment, if we focus at a certain point, equals to 180 degrees. Okay, and from these 4 equations, we found out that the value of that beta equals to 150 degrees minus theta, and if beta equals to 150 degrees minus theta, then sinus beta will be equal to sinus 150 degrees minus theta. And then we found out the value of sinus 150 degrees minus theta by using the second trigonometric identity that states that sinus alpha minus beta equals to sinus alpha times cosinus beta minus sinus beta times cosinus alpha. Here we substituted alpha by 150 degrees and beta by theta in order to find out the value of sinus 150 degrees minus beta. Okay, so actually sinus 150 degrees minus theta is sinus beta. Okay, so we actually found out by using this trigonometric identity that the value of sinus beta is actually 5 over root 7 times 2. After we found out the value of sinus beta, then we focused on triangle DEC. We used the law of sines in order to find out the value of DE, that is B. According to the law of sines, DC over sinus beta equals to DE over sinus 60 degrees. Again, according to the law of sines, in triangle DEC, DC over sinus beta equals to DE over sinus 60 degrees. Okay, but we know that DC equals to 4 units, and we have already found out the value of sinus beta. We know what the value of sinus beta, so the only missing, when we know that sinus 60 degrees equals to root 3 over 2, the only missing variable is DE, that is actually B. B is the only missing variable, so we put the data inside this equality, and we found out that the value of B is actually root 7 times root 3 times 4 over 5 units, and we have already found out that A equals to root 7 units. Here we found out that A equals to root 7 units, so we know the values of A and B. And what is the area of the green triangle? The area of the green triangle is the base of the triangle, that is B, times the height of the to the base, that is A, over 2. Okay, the area of the green triangle FDE equals to B times A over 2. We substituted A by root 7 and B by the value that we got for B, and we found out that the area of the green triangle FDE equals to 14 times root 3 over 5 square units. Or in terms of numbers, the area of the green triangle FDE equals to 4.85 square units. Okay, the area of the green triangle equals to 4.85 square units. Okay, thank you very much.